Good day everyone, I am Charles Christian Pasio, a BSc 3B student, and now I'm going to perform the performance task number 8, which is reporting. So first, we're going to discuss what is CPU. The Computer Central Processing Unit, or the CPU, is the portion of computer that retrieves and executes instructions. The CPU is essentially the brain of a CAD system, the component of a computer system that performs the basic operations such as processing data of the system, that exchanges data with the system's memory or peripherals, and that manages the system's other components. It is called the processor. Next is a bug. In computer technology, a bug is a coding error in a computer program. We consider a program to also include the microcode that is manufactured into a microprocessor. The process of finding bugs is before users do is called debugging. For example, a word processing application could crash while the user is writing an essay or report. This may cause them to lose work if they haven't hit save from some time, which result in a negative impact on productivity and bad perceptions of the product. Typos are also a type of bug. What is ENIAC or ENIAC? ENIAC in full is also known as Electronic Numerical Integrator and Computer, the first programmable general purpose of electronic digital computer built during World War II by the United States. The Electronic Numerical Integrator and Computer, or ENIAC, was the very first general purpose electronic computer. It was designed primarily to calculate artillery firing tables to be used by the United States Army's Ballistic Research Laboratory to help US troops during World War II. So we have now the people behind computers. Next is Robert Noyce. Robert Norton Noyce was also known as the mayor of Silicon Valley, was an American physicist and entrepreneur who co-founded Fairchild Semiconductor in 1957 and Intel Corporation in 1968. He invented an integrated circuit, or monolithic integrated circuit is a set of electronic circuits on one small flat piece of semiconductor material, usually the silicon. Large number of tiny MOSFETs integrated into a small chip. Next is John von Neumann. John von Neumann is perhaps best known for his work in the early development of computers. As director of Electronic Computer Project at Princeton's Institute for Advanced Study in 1945 to 1955, he developed MANIAC, or Mathematical Analyzer, Numerical Integrator and Computer, which was the time the fastest computer of its kind. He also made important contributions in the fields of mathematical logic, the foundations of quantum mechanics, and the economy and game theory. Next, what was the first CPU architecture? The first commercial microprocessor, the binary coded decimal or BCD based Intel 4004, was released by Intel in 1971. In March 1972, the Intel introduced a microprocessor with an 8-bit architecture, the 8008 and the 8008, an integrated PMOS logic re-implementation of the transistor logic, or TTL, based on data point 2200 CPU. So that is the picture of first microprocessor, or microarchitecture rather, the Intel 4004. Next is, what is front-end processor? It is also known as FEP. Is a small-sized computer which interfaces to the host computer a number of peripheral devices such as IEDs. Data is then transferred between the host computer and the front-end processor. A front-end processor is a small, limited capability digital computer that is programmed to replace the hardwired input and output functions of a central computing system. For example, for the control of remote terminals in a time-sharing system. A front-end processor is also used in a more general sense in asymmetric multiprocessor systems. The FEPs is a processing device which is closer to the input source than is the main processor. It performs some tasks such as telemetry control, data collection, reduce of raw sensor data, analysis of keyboard input, and many other more. Next is a back-end processor. A back-end processor is known as a host processor, a data processing company that contracts with acquirers to provide communications and processing systems that connect with interchange system for clearing and settlement services on behalf of those acquirers. Next is a cache memory. The cache is temporary memory, officially termed as CPU cache memory. This chip-based feature of your computer lets you access some information more quickly than if you access it from your computer's main hard drive. The cache memory is an extremely fast memory type that acts as a buffer between RAM and the CPU. It holds frequently requested data and instructions so that they are immediately available to the CPU when needed. A cache memory is used to reduce the average time to access data from the main memory. Next is instruction cache. The instruction cache contains pre-decode bits to demarcate individual instructions to improve decode speed. One of the challenges with the IA32 and Intel 64 ISA is that instructions are variable in length. In other words, the size of the instruction is known until the instruction has been partially decoded. Next is the instruction set architecture. An instruction set architecture, or ISA, is part of the abstract model of a computer that defines how the CPU is controlled by the software. The ISA acts as an interface between the hardware and the software, specifying both what processor is capable of doing as well as how it gets done. The three most common types of ISAs are: number one, stack. The operands are implicitly on the top of the stack. Accumulator, one operand is implicitly the accumulator. And the general purpose register, or GPR, all operands are explicitly mentioned. They are either register or memory locations. Microarchitecture. Microarchitecture is abbreviated as microarch or UARC. Is the fundamental design of a microprocessor. It includes the technologies used, resources, and the methods by which the processor is physically designed in order to execute a specific instruction set, ISA or instruction set architecture. The microarchitecture is a very specific design of a microprocessor, while a chip's architecture refers to the broader family of chips. For example, Intel's x86 family is the architecture, while NetBurst, Nehalem, and etc. are microarchitectures. Next is branch prediction. A branch prediction is an approach to computer architecture that attempts to mitigate the cost of branching. Branch prediction speeds up to the processing of branch instructions with CPUs using pipelining. The technique involves only executing certain instructions if certain predicates are true. The branch predictor is a hardware mechanism that predicts the address of the instruction following the branch. For respecting the sequential semantic of a program, the instructions should be fetched, decoded, executed, and completed in order of the program. This would lead to quite slow execution. Branch prediction technique can be of two types. First is the static branch prediction technique and the dynamic branch prediction technique. Next is speculative execution. Speculative execution is an optimization technique in which a processor or CPU performs a series of tasks before it is prompted to, in order to have the information ready if it is required at any point. Speculative execution can provide a significant increase in performance, but has been shown to endanger the security of privileged data in some CPUs. For example, the meltdown security vulnerability affects some Intel CPUs due to a flaw in their speculative execution. The reason it's speculative execution is that the CPU might be wrong. If it is, the system loads the appropriate data and executes those instructions instead. but branch predictors aren't wrong very often. Accuracy rates are typically above 95%. Next is register renaming. Register renaming is a form of pipelining that deals with data dependencies between instructions by renaming their register. Operands. An assembly language programmer or a compiler specifies these operands using architectural registers, the registers that are explicit in instruction set architecture. Register renaming is a technique to remove false data dependency right after read or WAR and right after write or WAW that occur in straight line code between register operands of subsequent instruction. So that's all. Thank you.